Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, we are going to continue from our topic, which is angles between lines and triangles. Inshallah, today we are going to be talking about parallelogram. A parallelogram is a quadrilateral that has opposite angles to be equal, having opposite sides to be parallel, and also have a equal length. That is, the opposite side that are parallel, they also have a equal length. Now look at this. This is your parallelogram. We have parallelogram A, B, C, D, and we are saying that the opposite angles are equal. If this angle is angle A, this one also becomes angle A. If this angle is angle B, this one also becomes angle B. That is what having opposite angles to be equal. And we also say that it has opposite side to the word parallel. This side is what? Parallel to this side, and this side is also what? Parallel to this side. Not just that. The sides that are what? Parallel to one another, they are also equal in length. If this one is 8 cm, for instance, this one becomes what? 8 cm. If this one is 4 cm, for instance, this one also becomes what? 4 cm. So for a parallelogram, it has opposite angles to be equal. It has what? Parallel side. No, the opposite side are what? They are parallel, and they are equal in the length. Now we have a special type of a parallelogram which we call what? A rhombus. A rhombus is a what? Is a parallelogram that has all the sides to be what? To be equal, and after it has the opposite side angle. The opposite what? Angles as well to be what? To be equal. So for a rhombus here, we are saying that this angle P is equal to what? This angle P. They are the same thing, and the angle that we have here, they also what? The two of them. The angle here and the angle here, they are what? They are equal. That is, if this one is angle Q, this one also becomes what? Becomes angle Q. So this side AB is equal to BD, BD equals what? BC, and BC equals what? CA. That is for the rhombus. So for the rhombus, it has what? All the sides are what? They are equal in length. The opposite side are what? They are parallel. This one is parallel to this, and this one is also what? Parallel to this, and they are also equal as well. And the opposite angle are what? Are equal. So today, what we are going to do today is that we are going to Theorem 4 and Theorem 5. For the Theorem 4, what we are going to have is that we want to prove that the opposite angle that we are seeing here, are they really equal? We want to prove that the opposite angles of a parallelogram, they are equal. Prove that today, inshallah. And we also want to prove that the opposite side, they are parallel. We want to prove that as well. That are they really parallel to one another? And lastly, we want to prove that the diagonals of a parallelogram bisect each other. That is, when you have a diagonal here, diagonal 1, and you have a diagonal 2, this is the point of what? Intersection. We now want to prove that if this one is I, let's say for instance, we want to prove that our AI is equal to what? DI. That is, if the diagonal has was 12 cm, in length, if it is 12 cm in length, we are saying that this part becomes 6, and this part also becomes 6. That is the diagonal at the point of intersection. Bisects. It bisects what? Each other. That is, for instance, if this one is CD, and our CD is what? 18 cm, for instance, this one becomes what? 9, this one also becomes 9. That is our Theorem 5 today. Theorem 4 is that we want to prove that the opposite angles are equal and the opposite sides are what? Parallel. While Theorem 5 is that I want to prove that the diagonals of a parallelogram bisect each other. That is what we are going to do, inshallah, today. Now, for Theorem 4, we want to prove that in a parallelogram, both pairs of opposite angles are equal, and both pairs of opposite sides are also equal. In other words, want to prove that this our angle CAB, this angle is equal to CDB, and we want to prove that our ACB, this angle, is equal to ABD, this angle. That's the first part. The second part is that we want to prove that the side AB is equal to side CD, and side AC is equal to side BD. So our guideline still remains that all those systems. Out of those systems, we have been able to state one of the two here. The first one is that we have been able to make our general statements. The general statement is that we know, we state here that both pairs of opposite angles of a parallelogram are equal, and both pairs of opposite sides are also equal. And the second, the second guideline is that we are going to have our diagram in case we have this, while the third diagram is what are we given. So given is also what we have stated here. That is, we are given what? Quadrilateral ABCD. So the given here is this. We are given what? A quadrilateral or what? Parallelogram ABC. Given parallelogram what? A, B, C, D. That is what we are given. Then after stating what we are given, the next thing is that we're going to state what to be proved. Do we have anything to prove here? Yes. We want to prove that this angle and this angle are what? Are equal, and this angle and this angle are equal. And for this side, the side that you have here is equal to what? The side that you have here. So in short, to prove here, our to prove is what? AB equals CD. AB equals what? CD. Not just that, we also want to prove that our AC equals what? Equals BD. That is the first one. We want to prove that what? AB equals what? CD. And we want to prove that our AC is equal to what? BD. Not just that, for the angle, we want to prove, this one is for the first one. For the second one, we want to prove that angle A is equal to what? Angle D, comma. We want to prove that angle B is equal to what? Angle C. That is to prove. To prove that this angle is equal to this is equal to this, and this angle, this side is equal to this side, and this side is equal to this side. That is our to prove. After to prove, the next thing is that we want to make our construction in case we have. Yes, we are going to have a construction here. Let's draw a diagonal. A diagonal from here to here. Can we see that? That's a diagonal. And after drawing that diagonal, so let's get it construction here. So our construction, is that we have been able to draw a diagonal. A diagonal what? Diagonal AB. So draw a what? A diagonal. Diagonal what? AB. So after we draw the diagonal, so the next thing is that we now go towards our proof. We go towards our proof. But before that, let's name this angle. Let's call it A. This one first, let's call it B. And this one, let's call it what? BI. This one, AI. So we can now go towards to proof. So our proof now. So we are going to see that now with the diagonal, we have been able to define our parallelogram into two. such that we have two triangles now. We have triangle ACD and we have triangle BAC. Sorry. We have triangle what? ACD and triangle BAC. We will notice one thing, that in this diagonal, our A will be what? AI. Why? That is alternate angle. And our B will be what? BI. That is also what? Alternate angle. So we have two triangles. We have triangle ACD and we have triangle what? Triangle BAD. So let's take note. So we can say that our proof is what? In triangles ACD, triangle ACD, and what? Triangle what? ABD, triangle ABD, triangle ACD, and triangle what? ABD. We notice that A equals AI. A equals what? AI. That is what? Alternate angle. That is what? Alternate angle. That is alternate angle. And we also notice that our B equals what? BI. That is also what? Alternate angles as well. That is also what? Alternate angles as well. So if your A equals A1 and your B equals B1, then we notice that we notice that our AC here is equal to what? BD here. That is what corresponding side. We know that before. So we notice that AC equals to what? BD. That is what? Corresponding what? Corresponding side. Our AC equals what? BD. That is what? Corresponding side. Not just that, we notice that if you look at this, the whole thing here, look at the triangle here, the one that you have here. You have this ABD and you have what? ACD. We notice that this side, this is what? Sorry, this side A, the diagonal AB. If you split this into two, we are going to have something like this, right? We also have something like this, right? We're going to have something like this. You have something like this. We now notice that this is A and this is what? D. This one we have A. This one also we have what? D. This one has what? A, this one has D. We notice that A and D is common to both what? Triangles. So let's say that from here we are able to observe that our AB is what? Is common. Is common to both triangles. Our AB is what? Common to both triangles. So if AD is common to both triangles, what we have been able to state before is that A is equal to what? BI, and A is also what? Equal to AI. So the next thing is that from here we observe that this triangle and this triangle, they are similar. In other words, from what we have been able to learn under congruent triangles, we notice that ACD is what? Similar to ABD. So if ACD is equal to ABD, it means that this side is what? This side, let's place it here. So we discover that this side, let's make the. So this side A, and we have B here, and we have B here. We now see that our AD, this one is also what? AD. No, having what? The same side here. We have a side here, and we have another one here. Sorry. So we have A and we have B. We have A, we also have D. This one is what? C. This one is what? B, right? So we now see that here we have AD. This side is equal to what? This side. And from what I've been able to state is that this side is what? Parallel to this side. So in other words, this side as well is also what? Equal to this side, right? And we say that our AI is what? Is equal to A and B is equal to what? BI. So the angle you have here is equal to what? The angle you have here, and the angle you have here is also what? Equal to the angle you have here. Meaning that we have been able to what? We have angles what? In common. We have what? Two angles, angle here is common to here. This one is also what? Common to here. So if this angle is equal to this angle, and this angle as well is also what? Equal to this angle, then from what we have learned under congruent triangle, it means that these triangles falls under case 2, which is what? Side, and what? An angle. So it has for two sides to be equal and one included angle. So if it has two sides to be equal and one included angle, it means that it means triangle ACD. It then means that triangle what? Triangle ACD similar to what? Triangle what? ABD. Triangle ABD. So if that is the case, then we can confidently state that what? That our side here, your side AD is equal to what? Side CD. Since the two triangles are what? Are similar. It then means that CD is what? Equal to AB. Under what? Under what we have learned under congruent triangle. So from that we can say what? Our AB is equal to what? Equal to CD. That is the first point. That is, we have been able to say that this side is what? Is equal to this side under what we learned under what? Congruent triangle. Now the second one is that what about the what? The angles. For the angle is very simple. We know that this is B and this is B. Right? This one is B, this one is BI. They are the same thing. Why? Alternate angle. This is A and this is what? AI. They are the same thing. Why? Because they are what? They are alternate angle as well. So invariably, what you have under angle A here is what? B plus A or A plus B. What you have under angle B is what? A1 plus what? B1. And B is B1. And A is also what? A1. So that means that the angle A is what? The angle D. Let's quickly write it somewhere here. So here we have A. We have our angle A equals what? A plus what? B. Right? And we have our angle what? Angle D. We have angle D, which is what? A1 plus B1. And we know that A equals what? A1 and B equals what? B1. It then means that if A1 is A and B1 is B, then C angle A becomes what? Angle D. So it means that the opposite angle are equal, and the opposite side they are what? They are parallel and they are also equal. So let's take note of that. In our substance. Now this is theorem 5. For theorem 5, what we want to prove that the diagonal of the parallelogram bisect each other. Here we have the parallelogram, which is ABCD. So what we want to prove is that our AI is equal to BI and our CI is equal to BI. So we have the first, under our guidelines, we have the first guideline, which is what? To make a general statement. And the second one is what? Is to state our diagram and go to the statement of given. So what are we given? We are given what? Parallelogram ABCD, given what? Parallelogram what? A, B, C, D is what? With diagonals what? AD and what? CD and diagonal CD. That is what we are given. Now, after the statement of given, then what's next? What's next is what? Our to prove. To what? To prove. Our to prove is that we want to prove that AI equals to what? BI. And also CI equals to what? BI. That is what we intend to do. Then after the statement of to prove, then what? We are going to make if there is any construction. So what are we going to construct? We want to construct or want to draw the two diagonals. And the two diagonals will intersect at I. So construction here. Draw diagonals AB and what? And CD to intersect at what? At I. To intersect at what? At I. That is our construction. Now, after making our construction, so what's next is that we go towards to prove. We are able to say 1, 2, 3, 4, 5. So what is now our proof? We want to prove. Now, we want to prove that this AI is equal to what? BI, and BI is equal to what? CI. You notice one thing, that in triangle AIB, in triangle AIB, not just that, and CIB, and CIB, in these two triangles, you notice that our A equals AI. Our A equals what? AI. That is what? Alternate angles. We also notice that our B equals BI. Our B equals what? BI. That's also what? Alternate angles. That is alternate angles. From that, we see that we now notice that this AC, or even not that, CD, this side is what? Parallel to this side. So mean that our AB and CD, they are the same thing. So from that, we notice that AB is equal to what? CD. That is what? Opposite sides of a parallelogram. Opposite what? Opposite sides of a parallelogram. If that is the case, we now see that you have one angle here. Can you see? Angle A, angle B. This one is what? Angle BI and angle AI. This A and AI, they are the same thing. Meaning that if this one is 40, this one becomes 40. This B is also what? BI. If this one is 60, this one also becomes what? 60. Right? This side is equal to this side. In that case, you will know that your AIB is what? Similar to CID. Similar to what? CID. Why? That is what? I see. This one is angle. This one is angle. The same thing. This one is angle. This one is angle. The same thing. This one is side. This one is what? Side. The same thing. That is under what? Under angle, side, angle. That is what? Under angle, side, and which is what? ASA. If that is the case, then we can say that our AB is equal to what? CD. Angle C equals what? Angle B. Angle A equals what? Angle D. If that is the case, then convenient, you can say that our AI here will be what? Will be what? DI. And our CI automatically becomes what? IB. And Y corresponding what? Side. So in that case, we can say that AI equals what? DR equals DI. Why? Because they are corresponding. That is what? Corresponding sign. And at the same time, our CI equals what? DI. That is what? Same reason. That is what? That's the same reason. So AI equals DI and CI equals what? DI. So from here, we know that the diagonals of a parallelogram bisect each other, and at the point of intersection, the what? The length you have here and the length you have here, they are the same thing. And this one and this one, they also work the same thing. So if the whole length here is 17 centimeters, this one becomes what? That be what? 8.5, 8.5. If the whole of this is what? 21 centimeters, this one becomes what? 10.5, this one also becomes what? 10.5. Please take note of that. So under the first theorem, we were able to prove that the opposite angles are equal and the opposite sides are also what? Equal. Under the second theorem, we were able to prove that the diagonals of a parallelogram bisect each other. That is, this length and this, they are the same thing. This and the same thing. So what we are going to do now is that we are going to take one or two examples, after which we are going to call it. Now this is example 1. We are told that in the diagram below we have to find the size of each angle. Look at this one. This one is m, this one is n, this one is 2s plus 40, this one is 4s minus 20. So what is the size of the angle? We know from what we have been able to prove is that the opposite angle are what? They are equal. This one and this one, they are the same thing. So this one and this one, they are the same thing. So very simple. What do you do? Just say what? 2x, right? Plus 40 equals what? 4x. Let me do like this. 4x minus 20 equals what? 2x plus 40. And why? Because opposite angles are equal. Write it. Opposite angles of a parallelogram. That is the basic. Then if that is the case, well, let's write that 4x minus 2x equals what? 40 plus 20, right? And that is what? 2x equals what? 60. If 2x is 60, then what is x? X becomes what? 60 divided by 2. And that is what? 30 degrees. So the value of x becomes what? 30 degrees. If x is 30 degrees, then what is the angle here? In that case, you can say that for this angle, angle 1, and what is that angle? That is 2x plus 40. That is what? 2 multiplied by 30 plus what? Plus 40. And that is 100 degrees. For the second one, what do you have there? We have 4x plus 20. That is what? 4 multiplied by what? By 30 minus 20, which is what? 120 minus 20, and that is what? 100 degrees. Now, this one is 100 degrees, this one is 100 degrees. Then what is n? What is n? Very simple. We are going to make use of the angles of the rule under that we learn under co-inferior angle. So here, if you have this angle and this angle together, they are going to give you 180 degrees. Why? Because they are co-inferior angles. If you have this angle and this angle together, they are also going to get to 180 degrees. Why? Because they are co-inferior angles. So for the third angle, we say that m plus 4s minus 20 is 180 degrees. Why? Because they are what? Co-inferior angles. Now what is m now? Our m becomes what? 180 minus, the whole of this is what? Is 100. That is minus 100. And that is what? 80 degrees. If this one is 80 degree, then this one becomes what? 80 degree. We know that n equals what? N. So if n is 100, then this also becomes, sorry, if n is what? 80, then this also becomes what? It becomes 80 degree. Why? That is what? Opposite what? Angles of a parallelogram. That is what? Opposite angles of a parallelogram. That's the reason for that. So inshallah, we are going to the second examples, and after taking that, we are going to call it a day. Now this is example 2. Under example 2, we're doing that ABCD is a parallelogram. If AEB, that is AEB, is 90 degree, we should find the angle X, Y, and Z. So what are we going to do? Very simple thing to do. The first one is that we can find our X directly, right? This is C, this is what? D. So from here, we can say what? Angle C equals to angle B. Why? That is what? Opposite angle of a what? Of a parallelogram. Opposite angles of a parallelogram. That is what our reason for that. So X becomes what? X becomes the sum of 36 and what? 32. And that is what? 68 degree. Very simple. Our X is what? It's 68 degree. If X is 68 degree, then, and we know the value of Z, yes. I say yes, because we know that when you sum your angle B and your angle B together, you are going to get 180 degree. Why? That is co-exterior angles. So the second one, this one is 1. So for the second one, we know that angle D plus what? Angle B equals to what? 180 degree. Why? Sum of a co-interior angle. Because it is what? Sum of what? Co-interior angles. So what is angle D? Angle D is not known. That is what? Z. And what is angle B? That one is what? 68 degree. And that is what? 180 degree. What is now Z? That is 180 minus 68 degree. And what is 180 minus 68 degree? We're going to get, this is 112. We're going to get 112 degree. So we need that our Z is what? Is 112 degree. If Z is now 112 degree, then what is Y? That is where the issue is. How are we going to know the value of angle Y? We will know that we have a triangle AEB. This one is 90, this one is what? 36. So what is this? So we can say that in what? In triangle what? AEB, right? We have 90 plus 36 plus, let's call this one what? K. So plus what? Plus K equals what? 180 degree. Why? That is a sum of angles in a triangle. Sum of what? Angles in a triangle. So we are going to have K to be what? 180 minus, what is 90 plus 36? That is 126. So minus what? 126 degree. And what is 180 minus 126 degree? We are going to get what? That is 54 degree. So K is what? Is 54 degree. If this one is now 54 degree, this one is what? Y. We know that the sum of this and this, they are the same thing. Or the addition of this and this is what? 180 degree. You can go to any area that you like. Either you add this one to 180 degree, or you pay this one and this one to be what? To be the same value. So from that, you can say that Y plus what? Plus 54 equals what? Z. What is Z? Z is what? 112 degree. What is our reason? That is what? Opposite angles of a parallelogram. This one is parallel, this one is gram. That is a parallelogram. So what is now Y? Y is 112 minus 54. And what is 112 minus 54? That is 46 plus 12. And that is what? 58 That is what 28. So add the 10 and 4 together to get what 112. So from here, we have been able to determine the value of x, y, and z. So therefore, in general, our x is what? X is 68 degree, right? Y is what? 58 degree, right? And z is what? 112 degree. So that is the answer. X is what? 68, Y is what? 58 degree, and Z is what? Is 112 degree. So that is what we get from that. So inshallah, we are going to call it a day today, and in our next class we are going to continue from this day. So you are going to take your assignment today. You take your assignment. Well, there are many of the questions. Please ensure that you go through the examples and the theory that we have been able to prove today, and after that, take your time to solve the question under your assignment. So we are going to take a question for the assignment now. Please make sure you take your time to do your question. So this is our assignment for question 1. We have to find value of x, y, and z in that diagram. So you have the first one to be 64. For the second question, you have A, D, and C, and you have the angle here to be what? This one is 124. So you have to find the size of your A, D, and C. And for the second one, we are given that WXYZ is a what? Parallelogram. Given that angle what? WXY is what? 72 degree. We have to find the other 3 angles. And for the question 3, you are told that in the diagram below you have to find the angles x and y. So this one is a what? A parallelogram. Can you see? That's a what? Parallelogram. And you have the line like this. This one bisects it, right? This one is 38 degree. This one is 40 degree. This one is x. This one is y. You have to find the value of x and y. Know that this side is what? Parallel to this side, right? This one is what? Parallel. Can you see that? So parallel means that this angle is what? Equal to this angle, and this one also what? Become this angle. So you are going to find the value of your what? Your y and the value of your x. Please take your time to do it and endeavor to quickly submit your assignment on the e-portal. Assalamu alaikum wa rahmatullahi wa barakatuh.